Okay, so let's move on to the last part of question 3. This is the never-ending lesson. So this first part, letter B, asks us to write an algebraic rule that represents the relationship between the side length of a pond and the number of tiles needed to surround the pond. So hopefully you realize that we've already done this. So we're going to come up and we're going to steal this 4s plus 4, t equals 4s plus 4. And we're going to use this for part B. So I'm going to write t equals 4s plus 4. It goes on to say, what do each of the numbers and letters in your rule represent? So let's start with the left. So the t. The t represents what? And we've been saying it this whole time that t is the number of tiles that we would need to put a border around that pool. Next, we should probably identify our s. And our s means our side length, how long the side of the pool is. But now they also want us to identify, what do these 4s mean? So let's take a look at this first 4. We're doing 4 multiplied by our side length. And the reason that we did 4 multiplied by our side length is because this 4 means there are 4 sides to the square. So we need to add up all 4 sides, not just one side. And then finally, we've also got this other 4 at the end, this plus 4. And this isn't a times, this is an add 4. And the reason we added 4 was because we had to fill in those corner pieces. So the plus 4, I'm going to put is for the, or Control Z, is for the corner pieces. And remember, like I was saying earlier, no matter how big your pool gets, you're always going to have 4 corners, but no matter how little your pool gets, you're always going to have 4 corners. And we showed that in our model pretty well. We're going to skip C because this asks us to do the same process for another algebraic rule, which we could, but this lesson is already long enough, so I'm skipping C. The next question wants to know, is the relationship in the graph proportional or non-proportional? How do we know? And what is the constant of proportionality? So let's come up to our graph. Here is the graph of our function. And remember, for a graph to be proportional, it needs to be a straight line, and it needs to go through the point 0, 0, which is origin. So origin is down here. And it looks like if we were to extend this line, it's not missing by much, but it's definitely not going through origin. So this graph would not be proportional. So is the relationship in the graph proportional or non-proportional? That answer is non-proportional. How do you know? We know it's non-proportional because even though it's a straight line, it did not pass through origin. And I'm actually going to type this. Change the size. Wow, what did I just do? that's my how do you know part. And then finally, what is the constant of proportionality? Well, that is a very silly question because if it's not proportional, there can't be a constant of proportionality. However, if we were to change this, what is the slope? Let's just change this to slope. The slope is going to be our rise over run, which our constant of proportionality would be the same. But since we're not proportional, we're not going to call it that. We're going to call it rise over run slope. So let's look at 2 points on our graph. It will allow me to zoom. Okay, so to go from this point right here, 1, 8, our scale is actually by 4. So this is a rise of 4. And our run, to go from 1 to 2, that's only a run of 1. So our rise is 4, our run is 1. Rise of 4, run of 1, which simplifies down to x4. And again, m is slope. Constant of proportionality would be k, and we do not have a k because it is not proportional. Last question, E. What does the point 0, 4 represent? So we're going to think about our first variable is our S, our side length, and then our second variable is our number of tiles. So the point 0.04 means that you need 4 tiles for a pond that doesn't exist, which that doesn't make sense because if you don't have a pond, you're not going to be needing any tiles at all. So let's put that into words. So for 0, 4, this means you need 4 tiles for a 0 by 0 pond. So does this point make sense? The answer is absolutely no. This one does not make sense. And that is because you would not need any tiles if the pond did not exist. That is only the first part of that question. So I'm going to cross this one out. What does the point 0.04 represent? Then we've also got this second question that says, what does the point 1, 8 represent? So let's type this one also. So this one is 1, 8. And this means that you need 8 tiles for a 1 by 1 pond. And does this make sense in this scenario? And yeah, actually it does, because we saw the example in our model where when we had a side length of 1, it required 8 tiles. I'm just going to write yes. This makes sense. So that was a very thorough lesson on the 4 representations or a function. And I hope you learned something in these last 2 days.